Welcome, everyone. I am Barbara Wadsworth, and on behalf of the Graduate Student Division, we wanted to welcome everyone and thank everyone for being here today for our first webinar in the Pioneers in Dairy Science webinar series. Our first speaker is Dr. Kertz, presenting a historical perspective on key aspects of applied calf nutrition. Dr. Kertz has been and remains an active member of the ADSA, serving as chair of the Foundation Board, initiating SBAC in 2005, receiving the Applied Nutrition Award in 2006, serving as a member of the Board of Directors as Secretary-Treasurer and Vice President, and he has been a pioneer in the field of applied calf nutrition and has extensive expertise in nutrition, feeding, and management of dairy cattle from calf, heifer, non-lactating, and through lactating stages. So without further ado, I will turn it over to Dr. Kertz.
Thank you, Barbara, and I'd like to thank the Graduate Student Division for making this work, not only Barbara, but also Amanda Sterrett at the University of Kentucky and Eric Testrode at Iowa State University. On the cover slide that you see, there's a website, and at that website I post the articles I write for Hordes and Feedstuffs, as well as those that are picked up for the Hordes Dairymen en Español in Mexico. So I point that out because many people aren't aware of that unless I point it out. Now, in terms of looking at this issue, let's first see what the national data tell us. There's the National Animal Health Monitoring System, which is part of the USDA, and they have done annual surveys, and you see in the years 91, 96, 2002, and 2007, they ask questions, survey questions about calf death losses. And the average is somewhere between 8 to 10%. It really hasn't changed much in over 20 years. Weaned calves, there's about another 2% mortality. Calves born dead, their various studies have shown it ranges from 10 to 20%. For the first time, that was included in a non-survey in 2007, and it showed 6.5%. I suspect that number is low because many dairies do not track this number very closely. The average age of first calving, you see, hasn't changed much at all since 1991, about 25.5. Generally agreed that 24 is good, and in some cases they may be lower at 22. An outline of this presentation will cover the following subject areas: colostrum, milk replacer, calf starter and hay, water, and as we'll see, these all interrelate with each other. And then we'll look at the longer-term impact of the calf period on the lactating cow. So let's begin with a part of the conclusion. There's increasing evidence that calves never really get over a good start or a bad start. I think there are three critical periods for a calf. The first one is what occurs around calving. That includes the cow, her health, her nutrition, her environment, how colostrum is managed, and then the next critical period is the first 2 weeks, because most calf death losses occur in the first 2 weeks after birth, and most of them are due to diarrhea or scouring. And then the weaning transition period, an area I think we need to pay more attention to. It's 2 weeks before full weaning and 2 weeks after full weaning. It's as important to the calf as the transition period is to a lactating cow. Colostrum is the first source of nutrition for a calf. And historically, we've said there are three primary factors, although how we look at those have evolved somewhat. The first one is timing. Colostrum should be administered at birth or as soon as possible after birth to the calf. The calf is not born with any antibody because antibodies don't cross the placental wall from the cow to the calf in utero. As a result, colostrum is the major source of antibodies to the calf, and the calf has a unique ability to not digest and break down those antibody proteins initially. It can absorb them whole through the intestinal wall into the bloodstream, and that's where it gets its initial immunity. This is time dependent. The longer after birth before colostrum is administered, the absorption efficiency decreases. For instance, in the first 4 hours, it already decreased by 25%. And after 24 hours, it's virtually nil. The next part is the quality. That is the amount of antibodies in colostrum. It can be determined indirectly with the colostrometer because that measures the amount of solids, and somewhere around half of the solids in colostrum can be protein, primarily antibody proteins. So if we want to provide a minimum of 100 to 200 grams of the immunoglobulins, and we have a colostrum quality of 50 grams per liter, then we can see that the quantity is very important. And we used to say only 2 liters, but if you had 2 liters at 50 grams, that only provides 100 grams of IgG, the lower end of that scale. It's best to have 200 grams, and that would mean 4 liters at the very first feeding. So these are the common factors we've taken into consideration. But more recently, we're finding out there's another one that we haven't paid much attention to, and that is how clean is it? How uncontaminated is it? Before we get to that, let's take a look at what can affect absorption, because that is one of those factors. Any stress reduces absorption. That can be due to heat stress in the summertime when a calf is born. That can be due to calving difficulties. That's stressful for the cow as well as for the calf. It can be due to how well the calves are handled and fed after they're born. And the greater the concentration of IgG in colostrum, the higher is the absorption efficiency. So you have a double positive effect. And it's been found that the higher the bacterial contamination, that decreases the antibody absorption. We don't know for sure if that's a direct effect or an associated effect. In terms of clean colostrum, the first route of possible contamination is how clean is the udder when the cow is milked for colostrum. It's generally now accepted that the total plate count of bacteria in colostrum should be less than 100,000 colony-forming units per ml, or in terms of total chloroform counts, less than 10,000. In the last 5 years or so, there have been at least a handful of field trials done sampling colostrum from dairies to see what this contamination is. And from 1/3 to 90% of them exceed those levels. So the 3 sources of bacteria in colostrum are those directly from a dirty udder, or from contaminated equipment that used to milk the cow, to feed the calf. And this has been found to be the primary source of contamination. And then, of course, if the colostrum sits around, especially if the temperature is warmer, then there's extensive bacterial proliferation because colostrum is a great source of nutrition for bacteria. So in order to optimize colostrum quality, the first thing is to make sure that the udder is clean. Next, to make sure that all of the equipment that's used to collect, store, or feed colostrum is sanitized. And then do not pool it, especially if you're looking for disease control such as Johne's, because if you pool colostrum from several cows, you may then inoculate several calves with that colostrum. And then if the colostrum is not used right away, to refrigerate it, certainly within 2 hours or less in hot weather. And if it's not used within 3 days, it should be discarded, or actually, if you know it's not going to be used very quickly, it should be frozen. This has led to quite a bit of work about pasteurizing colostrum, and the main work in this area has been done by Dr. Sandra Godden at the University of Minnesota Veterinary College and her graduate students. She's found that if you're going to pasteurize colostrum, you should use a batch pasteurize, not a high-temperature, short-time pasteurizer that's used in, say, commercial milk processing operations, because the solids level is so high on colostrum that it will plug it up or gum it up. and that the time and temperature is very specific. Pasteurizing at 60 degrees centigrade, warming it up over a 30-minute period, and holding that temperature for 60 minutes, and then decreasing it over another 30 minutes. If you go above that, or as you go above that 60 degrees centigrade, the IgG activity is being lost. It will be decreased. And since colostrum is very thick, there should be an agitation system so that it's stirred constantly and it has a more even heat distribution. The time and temperature should be monitored routinely, and there should be periodic cultures of the raw and heat-treated colostrum with a goal after colostrum, after pasteurization, that the total bacteria count should be less than 20,000 units. Because remember, pasteurization is not sterilization. And in these studies, you found that the absorption efficacy of IgGs can be increased by decreasing the bacteria count, in one case from 27 to 35% absorption efficiency. And since this is an ongoing process, there should always be control and monitoring. The colostrum values beyond just the antibodies. It has a high level of solids and twice the normal level of fat, high levels of vitamin A, which is essential for tissue development, and also fat soluble, so it can be stored in the calf's liver or fat. It has higher mineral content. And then over 200 bioactive compounds have been identified in colostrum. And these do things such as foster intestinal development, facilitate nutrient absorption, and help exclude bacteria from being absorbed into the bloodstream. This study was done in Wisconsin with a registered brown Swiss herd, actually done in the 90s, but not published until 2005. In this registered herd, 68 heifer calves were born that year, and they were fed at very first feeding either 2 or 4 quarts. That's it. Either 2 quarts first feeding or 4, just splitting out among those 68. And what they found was at the time the calves had been grown into heifers and were at breeding age and they did a tape weight, they found that those that had gotten 4 quarts or liters at the very first feeding of colostrum had 0.23 kilograms more daily gain. And then when they looked at the lactation, you see in the graph, in the first lactation, those that had received 2 liters of colostrum first feeding versus 4 liters, the 4 liters had 11% more milk in the first lactation, and that increased to 17% more milk in the second lactation. This was a very eye-opening set of information, very simple data. And the only difference was 2 versus 4 quarts or liters at the very first feeding. And now let's look at the milk replacer side. What is a milk replacer? Well, it somewhat depends on how you define it. I think the first milk replacer was really when farms would be smaller and the milk would be taken through a separator and the fat skimmed off and used to make butter or sold as cream. So the skim milk that was left was then a byproduct and was often fed to calves or pigs as a liquid milk replacer. And I think that's most likely why the earlier dry milk replacer, made from dried ingredients, had what is now considered lower fat content, which was 8 to 12%, because skim milk has virtually no fat. The weaning and feeding and weaning programs of milk replacers for calves were heavily influenced by studies done in the 50s, 60s, and 70s. It was sort of a golden area of rumen development work with calves. And Dr. Dick Warner at Cornell University was a part of that group. At that time, the objectives of feeding calves milk replacer was to minimize the cost and amount fed, and to wean them early by encouraging calf starter intake and rumen development. and we'll look at this study by Porter et al. Later. These calves would typically be weaned at 1 month of age, had a low daily gain, and a low feeding level of milk replacer, because the emphasis was really on the starter and rumen development. Over a period of time in the 80s, the fat and protein, or protein and fat level in milk replacers somewhat gravitated, I don't think it was done on a nutritional basis, to about a 20% protein, 20% fat milk replacer, commonly called an industry standard, even though there really isn't any such thing. And what we'll see is that there's an inverse relationship between the amount of milk replacer and its fat level and starter intake. And, of course, that can affect when you can wean calves and how well they'll wean. And then, of course, we have in the same picture, we need to have water, clean water available for calves, and we'll see in a little later how important that is. And then in addition, in northern states, and even in southern states in the winter, calves get cold stress. Anything less than 15 degrees centigrade, which is about 59 Fahrenheit, is cold stress. Around the year 2000 and since then, milk replacer programs began to change, with the emphasis being on not limit feeding calves milk replacer, but feeding more to accelerate or normalize what was their possible growth rate. And so a series of studies were done. Diaz et al. Was at Cornell, Mike Van Amberg's group, Blom et al. At University of Illinois, Dr. Jim Drakely's group, Brown et al. At Michigan State, part of Miriam Weber-Nelson and the Mike Van de Haar group, and then Bartlett et al. At University of Illinois again. And they found that if you increase the milk replacer protein level as well as the feeding levels, you got increased daily gains. And that if you did this properly, the composition of body weight gain was not due to fattening, but true growth and development. And here's an example from one of those studies at Cornell, in which male calves with the same initial body weight were fed 3 different milk replacers, so that the amount of protein they got and the total energy they got was the same, and the same daily gain of about 0.6 of a kilogram. These calves were sacrifices and their body composition measured. And you see in the graph, we put the body composition on a dry basis because moisture in body weight, or water in body weight, is inverse in its content to fat. As fat increases, it displaces water. So if you look at it on a dry basis, you won't have the confounding effect of the water content. And you see as the fat in the milk replacers increased, the amount of fat in the carcass increased, while that reduced the concentration of the bone or ash and of protein. So the fatter calves on an actual weight were about 11% when they had 31% fat milk replacer, as opposed to 15% with the 8.5% body fat at that point. And that really became the basis for the first milk replacer in that group of accelerated or intensive milk replacers being a 28 protein and 15% fat. A National Research Council publication on the nutrient requirements of dairy cattle in the 2001 edition, which is the last edition, for the first time had a major section on calves and a young calf software model. It provides the opportunity to put in either body weight and ambient temperatures in either English or metric on an as-fed or a dry basis, and then you can add to that into that program. It has a library. You can pull out what milk replacer and starters in the library, or you can modify those to what might be on hand, and then run the iteration and see what it projects the daily gain of the calves would be. It will give you the answer in terms of the energy available for gain as well as the protein available for gain. So it's a very good tool and a major improvement in our ability to evaluate calf feeding programs. If we go back to the NOM study in 2007, which was actually done in 2006, you see there's quite a range in dairy farms in how they feed liquid to their calves. It varies with the size of the herd, less than 100 cows, 100 to 499, 500 or more. And note that the non-medicated milk replacer is more popular with the larger herds, and I think that's because they prefer to treat the calves if they have a problem rather than have medication in across the board. And that's why the medicated milk replacer in the second line is generally used at a higher proportion than the small or medium. But I should point out that this was before there was a significant change in limitations in medications allowed. That was about 4 or 5 years ago. You see unpasteurized waste milk, about a third of the dairies were using that. Pasteurized waste milk, less except for the larger dairies, which have more resources and can put in pasteurizers and protocols and so on. Unpasteurized saleable milk, pasteurized saleable milk, and other milk. If you add up the right-hand column, you'll come up with about 130%. Now what that means is that many dairies use a variety of programs. They may feed some milk replacer and then as well as some pasteurized waste milk or some combination. So there's quite a variety of programs followed by dairies. Now let's look at an example of a traditional 20 fat, 20 protein versus a 28 protein, 15 milk replacer. This is a study done at the University of Illinois. And if we look at the yellow column, you see we're a little over half a kilogram, which is be about 1.25 pounds a day being fed. And that's fed at a constant level across 5 weeks. And then in the 6th week, that would be cut in half by eliminating 1 or 2 milk replacer feedings. And at the end of 6 weeks, it would no longer be fed. If we look at the red columns, that being the more intensified feeding milk replacer, you see there was a percentage of body weight being fed, and so it increased up and then leveled off a bit and then was reduced before full weaning at the end of 6 weeks. Now, if we look at the starter intake at the same time, this is the starter fed to the 2020 milk replacer, and then the green column is the starter fed to the 2815. You see there's very little intake in the first week. But it's important to start then because intake should approximately double each week. In the 2nd week, you see that it's increased. In the 3rd week, you can see that there's quite a little bit of a disparity in starter intake between that 2020 milk replacer and the 2815. And that's because, as I said earlier, the more milk replacer and the more energy they get through the milk replacer, the more that limits their starter intake. It does progressively increase, though, because the calves are getting larger, and as they get larger, that will lead them to eat more. So the weaning program here was quite simply in that 5th week, 1 of the milk replacer feedings was eliminated. At the end of 6 weeks, they were fully weaned. Now, we need to do this in a transition because I was talking earlier about the weaning transition program. So that would be these 2 weeks and then the 2 weeks after full weaning. And we see that there is this disparity in starter intake, but it picks up after full weaning and comes back close together. And if you don't have too big a difference, the calves can adjust their intake and will adjust their intake. If we look at the weights of these calves, body weights, we see at the end of the 1st week, there's already a difference showing up between the 2 groups, being less for the 2020. And then that difference somewhat broadens until we get out to full weaning and then holds its way all the way out through 10 weeks. as we'll see in a little bit later, it's been pretty much agreed to that a good program should approximately double the birth weight of a calf by the end of 2 months of age. So if we start out with a 40-kilogram birth weight for female Holstein calves, for instance, and these were Holsteins, you see that by the end of 8 weeks, that's here, if they start out at 40 kilos body weight, now they're at 80. So that's a doubling. And if you look at the conventional milk replacer program to 2020, it's about 10 kilograms less. So if we look at the approximate intakes of the starter that should be occurring during this period of time, before you begin to reduce the milk replacer in half, the starter intake should be approximately a half a kilogram a week. Then when you remove half the milk replacer intake by eliminating one feeding, it should double to a pound or to a kilo. And then the week after complete weaning to 2 kilos, and then the week after that, 2.3 to 2.7, somewhere around 2.5 average. And if you, no matter what age you wean them, if you have this progression, then you should minimize any really negative effects from weaning the calf. That's why this period of time is very critical. So that leaves us with the question, well, is there an additive effect from how much colostrum you feed as well as how much milk replacer you feed? And this study was done at Cornell, and they used a large number of calves. These were on automatic feeders, so they could program them. At the very first feeding, there were 2 levels of colostrum, either 2 or 4 liters. You see here, 2 or 4 liters of colostrum was fed. Within each of those groups, there was 2 levels of milk replacer fed, either 4 or 12 liters. They were all weaned at 52 days and then measured at 80 days and 101. So if we look at the table, those that fed 2 liters of colostrum, their IgGs did not differ whether they were later fed 4 liters or 12 liters of milk replacer. And the minimum IgG should be 10, and it's probably a better idea to have it be 15. So that would be close to that 15 target. The daily gains did not differ much between the 2 milk replacers feeding levels, somewhat surprisingly. And the daily gains at 3 weeks later did not. There was a hip height increase effect, though. It went from 12 to 14.4 when they were fed 12 liters instead of 4 liters. Now let's look at the 4 liters of colostrum. The first thing you notice is that both of these levels were almost double what you had here because of feeding 4 liters of colostrum. So we have very high IgG levels now. The daily gain at 80 days was significantly higher when they were fed 12 liters versus 4 liters, 0.78 versus about 0.6. The daily gain 3 weeks later was similar at about a kilogram, and then the hip height was 4 centimeters greater for those fed 12 versus 4 liters of milk replacer. So there is an additive effect from the amount of colostrum fed as well as the amount of milk replacer fed. Now let's look at the calf starter rumen development side of it. From a historical perspective, there were studies done in Ralston Purina in the 30s and 40s with the effect of roughage on milk fat, and some of those studies are published in the literature at that time. Then from the 50s through the 70s, there were studies, extensive studies done at Iowa State by Professors McGilliard and Jacobson, graduate students Sutton, Hubert, Tamati, and Morrow. At Cornell by Professor Warner and graduate students Flatt, Sanders, and Harrison. And the National Institute for Research in Dairying in Reading, England by scientists Stovall, Roy, and Balch. One of the issues in the earlier studies, and still somewhat of a problem, is that there are often too few calves for treatment to pick up significant differences. And you can find a reference there that reviews this area in the Journal of Dairy Science. Warner in 1956 and some other authors along with him did an extensive review that's a good piece of literature to review. They found that studies as far back as 1932 showed that even calves on a milk diet had rumen volume development but not rumen function development, so it was retarded. And Trotman in Germany in 1932 reported roughage was not required for development of pillars, compartments, and papillae of rumen, and it still is often felt that you need hay in young calves, but it really has to do with the development and the function of the rumen at the time. And then you see some other key points there about rumen development. For instance, Kessler and others at Penn State showed that the most rapid rumen change was between 4 and 6 weeks. Blackster in the UK found that roughage did develop a larger rumen volume because it expanded. And then Flatt at Cornell, a graduate student at that time, found that there was a considerable increase in the ratio of the reticulorumen to the omasum abomasum from birth to 6 months into adult cattle. If we look at some of the studies that were done by the group at Cornell, they found that it was the end products of rumen fermentation rather than the coarse nature of the feed that was the stimulus for development of the rumen. And in infusing various acids like acetic, propionic, butyric, as well as glucose and sodium chloride, they found that the VFAs were the ones that stimulated papillae development in the order of butyric greater than propionic, which was greater than acetic. Now, implicit in this, as we'll see, you don't want to have acidosis because then you won't have normal rumen function and development. There's another study they did at Cornell which showed that if you have an extreme diets like a very high concentrate after they're weaned, and you notice that with only 18 kilos of milk replacer being fed, that's the low milk replacer feeding early weaning program. The daily gain was greater when they had up to 90% of the diet post-weaning coming from concentrate, whereas when they had 90% of it coming from forage, they only ate 75%, and their daily gains dropped from 0.5 down to 0.3. And it was noted, and this is a direct quote from the publication, that these calves with the high hay-fed diets were thin, pot-bellied, and unthrifty. And in their studies, they also measured rumen papillae development. They found when calves were strictly fed milk, there was very little papillae development, less than 1 millimeter. If they were fed a high hay diet, there were some, 4.1 millimeters. No consistent pattern difference with different treatments of hay. With concentrate, high concentrate, there were 7.5 millimeters. And again, no distinct differences with the treatments they had. And 3 main shapes, a spade shape, a triangular, and a hair-like. The group in National Institute for Research in Dairying did a series of studies, and here's an example from one of theirs that shows the effect of hay in diets of calves that were sacrificed at 12 weeks. They fed a fixed amount of concentrate, and you see as the concentrate, let me get my pointer, as the concentrate increased, then the amount of hay that they ate decreased. So at the highest level of concentrate fed, the lowest level of hay was consumed, and that resulted in the highest rate of daily gain and rumen papillae development. So as the diets got higher in hay, it had a more negative effect on daily gain and papillae development. And the primary reason that you can see is when they took the weight of the reticular rumen as well as the total gastrointestinal tract, they found that as the forage level of the diet increased, the amount of material, the gut fill, and the tissue associated was greater. So there was a confounding effect in that the more hay was fed, the more gut fill, and that distorted true body weight gains. More recent studies at Penn State, and you can find more of these pictures and slides at this website, an extension. And you see that with the milk-fed calves, there's very little development of papillae. With the combination of milk and then the grain starter, there's much more development. This is actually reticulum area. And then with milk and hay, there's little development. Because remember, it's the proportion of the volatile fatty acids that stimulate the development of the papillae. So in terms of calf starter characteristics, it's important that the calves like it, it's palatable, and it does not have fine material because they do not eat fines very well. It's sort of like if we were eating a cracker versus crumbling it together and eating it. It needs to have some particle size and not all pelleted, and we'll see why in a moment. Adequate protein, a minimum of 18%. Its fermentation in the rumen is really what leads to development of the rumen. And we also saw a little bit of the substitution effect, how much milk or milk replacer and its fat content influences the starter intake. And then, of course, is critical during the transition from weaning. In 1973, Dr. Warner had this quote in this publication at the Cornell Nutrition Conference. Hay has long been regarded as a sacred cow of calf feeding. Early suggestions to eliminate hay from a neonatal calf diet by a prominent feed company were labeled by us with little wisdom as heretical and a commercial ploy to sell more calf starter. They, in fact, may have been ahead of their time. This comment was based on a study that was done by John Porter, a graduate student of his. And so we're going to look at that study. You notice it wasn't published until 2007 because it's one of those things that never got published, and I kept running into situations in the field where I knew the importance of the texturized starter, but there were no published data. So I got back in touch with John Porter, who was an extension dairy specialist in New Hampshire, and we put together a paper. Unfortunately, Dr. Warner had died before we were able to get this published. And that study was a 2x2. There were two levels of fiber, and then a pelleted versus a texturized calf starter. The two levels of fiber had some impact, but not to the extent that the pellet versus the texturized did. So these calves were then weaned at a month of age. Remember, that was a common feeding program at that time. So if you look at the daily gain in the second month, for the texturized, it was significantly greater, 0.64 versus 0.51, and then overall greater, and that was due to more starter intake during that second month as well as overall. They made some observations. You know, graduate students do all sorts of things, and one of those was observing calves to see when they're ruminating by chewing. And they found that the calves fed to texturized starter had the earliest rumination at average of 3.7 weeks versus not until 6 weeks for those fed to pelleted. The percent of time ruminating was 21% for the texturizers versus only about 9% for those fed the pelleted one. They had heifer calves and bull calves, and some of the bull calves were sacrificed, and found that the rumen pH was only 5 for those fed to pelleted starter, whereas it was 5.4 for those fed to texturized. And they had more papillae length, 3.5, and a greater proportion of muscle to mucosa. Probably the most amazing numbers here are the differences in digestibilities. Dry matter digestibility was 5 units greater for those fed texturized, 15 units greater for ADF, and 12 units greater for this. And why would this be occurring? Well, it's because these calves fed to pelleted are acidotic, and when they're acidotic, the bacteria in the rumen don't function as well, and digestibilities are reduced. So that's the reason that I have advocated the feeding of texturized starters rather than pelleted starters. I took this picture of a texturized starter, but it's not really what I'd like to see either, because while you notice there are oat particles there you see them, and some cracked pieces of corn, which is good. But if you look at this, you do see besides the pellet, there's quite a bit of material that is finer material. And so I was able to make a recommendation on how to make a better quality pellet so that you minimize or eliminate the fines, and then the calves will eat it better and do that much better. Anybody have any idea what these calves are doing? If you were standing there, you could tell by the noise, the sound. The calf on the right is chewing wood. And this is what you sometimes can see when they're fed an all-pelleted starter and don't have any hay available, because they're marginally acidotic. And by chewing on wood, that causes them to salivate, which buffers the rumen. So they're like treating themselves. There are some recent pelleted starter studies, and you'll see that they help complete the picture about what occurs in the rumen of calves. In this first study by ACAN et al. From the University of British Columbia, there was a texturized starter by definition that was fed, and that's because it was commercially produced, and that's what it was branded as, a texturized starter. But the data show it's very poorly texturized because it only had 37% grains, and each of those were processed, and they don't necessarily need to be unless it's barley. And the rumen pH was 5.06 for those fed that poorly texturized starter. When they also provided some hay with that starter, then the pH went up to 5.49, and that was a highly significant difference. But there was a downside or a confounding effect to this. They slaughtered and sacrificed some of those calves, and when they measured the gut fill, those that had been fed hay had 4.7 kilograms more fill that are 59% greater than those not fed the hay. Then more recently, when oat hay was provided along with the pelleted starter, it helped increase the pH from an acidotic 5.05 to a higher 5.8. But in this case, we couldn't tell for sure what impact the hay might have had on daily gain because there was no gut fill measurements made. Now, what's the most common unrecognized problem with feeding calves? It's one that I don't see as often anymore, thank goodness. That's failure to separate water and starter containers. So let's look at water. Why is water important? It's the most essential nutrient needed in greatest quantity. The calf body, when born, is 70% water. It's the highest it'll be because it only has about 4% fat. There's an inverse relationship between water and fat. Some feel that calves have diarrhea or scour when water is available, when actually we found in the study that I'll review in a moment that calves, when the calves had diarrhea and they begin to dehydrate, they'll drink more water. It's directly related to dry matter intake, 4 times it. And some say, well, I don't feed water because it's a hassle. But I found that good managers who get good results figure out how to feed water. So if we look at an old study then of what happens with an early weaning program when water is not fed, to calves we see that their starter intake was quite a bit less, weight gain was less, and if you look at the ratio of water to starter intake, it's about 4 to 1. If you look at this on a larger scale, more recent study done by Jim Quigley when he was part of APC in Iowa, you see the 3 different milk replacer treatments are colored. And this graph is a ratio of water to dry matter intake with time on the study. So while they're still being fed the milk replacer, the ratio is only about 2 to 1, but that does not count the water coming from the milk replacer. After they wean, it jumps up to 4 to 1. There's always some variation, but it shows that 4 to 1 ratio. And then what happens if you don't separate those containers? Well, here's an older study that was done in which when we physically separated those 2 containers, the daily gain, this would be in the 2nd month after they're fully weaned, was increased by 0.12 kilograms, and that was associated with 0.26 kilograms more starter intake and 2 kilograms more water intake. You know, it's about a 4 to 1 ratio here. So why would there be that big difference? Well, if we look at this picture, at first glance, this looks pretty nice. It actually was taken near the end of March in a snowstorm in Wisconsin. So this calf is about 4 weeks old. There's plenty of a texturized calf starter here. In fact, you might say there's too much because the calf's not likely to eat that all in one day. And you see the water level is right here. So as I said, at first glance, that looks pretty good. But when I walked forward and took a picture straight down, here's what I found. What calves will do is they'll take a bite of this and start chewing on that and then swing their head over and dunk it in the water and take a drink of water. When they do that, they drop some of the starter in the water. Then as they've taken their drink of water, they'll pull out, swing their head back, and eat some more starter. If you put your fingers in the starter, you can feel it's wet. So if there's no physical separation between the 2 buckets, then the calf will swing its head back and forth, and it doesn't like dirty water or wet starter, and that's why the intake of both will decrease. Some places, this is not an issue. As you see here, a very common setup in the western United States, clear separation, no dirty water or wet starter. Now, what are dairies doing in these areas? If we go back to the NOM study, we see that it varies somewhat with the size of the dairies, small, medium, large. But in general, they're not providing water till they're in about 2 weeks old, and that's really too late. They're not starting to feed starter until they're close to 8 or 10 days old, and that's too late. And they can't begin to wait to feed more hay, and that starts as little as 3 weeks. There's a more recent study done in 2011 of heifer raisers, and it shows that maybe the practice is getting better because they're providing water and starter, but still waiting until 7 days of age, but not feeding hay until after about 2 months. One of the reasons it's important to really how we feed these young calves is because their feed efficiency is the greatest at converting nutrients to growth on a dairy. If we look at this data from a large calf and heifer ranch I've worked with, and Alex Bach from Spain provided the data, you see that from 2 months to 21 months, the average daily gain is somewhere about 850, 900 grams. As calves grow into heifers and become larger, they will eat more. And you see the dry matter intake increases. Well, if you do a ratio of feed to gain, as they get larger, the ratio gets poorer and poorer. And that's because with greater body weight, it takes more energy to provide maintenance requirements before that which is in excess of maintenance can be used for growth. The importance of the body weight was shown in this study in this 25 more years ago from DHI data in the Northeast U.S. And what they found was that they took the first test day after calving, did a tape weight of the body weight of first calf heifers. And they found a quite wide range of body weights, from 409 kilos all the way to 681. They took the 409, the smallest kilo body weight heifers, as the reference point. So milk production was zeroed out at that point. And then as they were larger, they plotted the milk the milk production from the larger heifers to what was produced by those that were smallest. And you see the curve that they achieved was that as body weight increased, which we're making some assumption there was increased development, the amount of milk produced also increased until it settled out at about 630 some kilos, and then it actually began to decrease. And the decrease may be because if they're starting to get fat, then there's problems with calving, and production is usually impaired as well. More recently, a fairly extensive field study was done at Penn State with 21 herds in Pennsylvania, 10 years of data. And they found if calves had a difficult birth and the number of days they were ill, they had a later age of first calving and had lower first lactation production. And the amount of dry matter intake from milk, milk replacer, grain, and forage did affect the growth of young calves. Their weaning dry matter intake, the days they were treated for respiratory illness, their body weight at first calving, all affected first lactation milk production. And lifetime milk production was similarly affected, but not to the same extent as first lactation. So these are some key field data. A more recent study with 10 years of calf growth data from the Cornell University herd. You see 1,244 records. And one of the things that was helpful in this study was that they were mostly fed the same milk replacer, that 2815, so there were not variations in the types of milk replacer fed. And then another New York herd, a commercial herd up near Watertown, was found that had 5 years of data, fed a similar milk replacer program on that period of time. And Dr. Bob Everett was a scientist, a geneticist, who was instrumental in developing the test-A model for cows, where you take one milk weight a month and use that to project out their lactation. He helped develop a calf model from this data. There was quite a wide range of daily gains from birth to 2 months of age. You see a 0.1 kilo a day up to 1.59. And within that range of data, they found if there was 1 kilogram difference, let's say you go from a half a kilo to 1.5 kilo a day, those heifers that grew faster produced 850 kilograms more milk during their first lactation and 2,280 kilograms more during their first 3 lactations. The other question that surfaced was, why was there such a wide range? Well, when they plotted the data by months of the year, they found it was because during colder weather, there was not an adjustment made in the milk replacer feeding program. So calves were more negatively affected. And in fact, in really cold weather, they may not gain any weight at all. So those calves did not do as well when they became first and later lactation cows. And the extent of this can be found by using the young calf model in the NRC program. So for instance, for a 45-kilo calf, it will lose 1/10 of a kilogram daily gain per 5 degrees centigrade below that 15 if there's not an adjustment made to provide more energy. So in summation, if we look at the calf-heifer timeline, we want to feed 4 liters of high-quality colostrum that's clean right after birth. We want to double the calf birth weight by the end of 2 months. And that would take an intensified milk replacer program for at least 6 to 8 weeks. Feed a texturized starter for 2 months with no hay. And then the 3rd month is still really a transition month. And so we want to minimize the amount of hay being fed so that they don't have gut fill, and that limits their efficiency of growth. And have a smaller group of 68. And then from birth to becoming a first calf heifer, they would increase typically their height by 60 centimeters. 50% of that occurs in the first 6 months. So that's really important period as well. And then the daily gain of about 850 grams from 2 months of age until they become first calf heifers at about 24 months, weighing about 635 kilograms. Thank you.
Great. Thank you, Dr. Kertz. At this time, we can take any questions that anyone has. I have one, Dr. Kertz. My screen went blank, so I can't see anything. But there's so many great new research constantly being published. How can producers and kind of extension associates sort through everything and make sure they're up to date?
Oh, that's can be a difficult challenge. If you noticed, there's in some of the slides I referenced the review that I did with Jim Lofton from Milk Specialties at the time, and that was published in the August issue of ARPAS about the history of milk replacer feeding programs, where I tried to describe these interrelationships in more detail than I could do today. So that is information that's designed for field people. And then that's the reason I write columns for feedstuffs in hordes, so that I try to take research trials and then pull out the essence of it and then try to develop some practical application from that. So I think that's our challenge of all of us as scientists, is to, especially if we're working with people in field and dairy operations, is to do that sort of thing. And that's why I've been doing this, and hopefully this information can be used as reference as you encounter these kinds of questions. Unfortunately, too often on dairies, the calves have been a forgotten area because they don't produce any milk and they just cost money. So unless you realize the importance of how you feed and manage them for when they become cows, then the level of importance is not there. So it's all a matter, I think we all have to develop a knowledge base and an understanding so that we can help the dairies.
Great, thank you. And I see that Amanda Barrett has posted a question.
Okay.
And she was wondering, what happens to calves who eat only milk or milk and hay as weaned heifers and as lactating cows? And how long does it take for them to develop papillae once on a weaned diet?
That's a couple questions. Let me try to back that up. Unfortunately, I don't think anybody's ever tracked that, because it's only in the last several years, as you see, that there's been data published that shows the impact of the calf period on their subsequent performance as cows. So I don't think anybody's tracked that. And as well, I don't think anyone has tracked how long it takes for calves to develop rumen papillae, although there are studies, and the Penn State website will show more extensive rumens than I showed, that you can have good rumen papillae development at 6 and 8 weeks. And if you do that then with a good texturized starter without the hay, then the calves can begin to utilize the hay without being set back. If you try to feed them a diet with 50% forage after 2 months, then what's likely to happen is they'll have quite a bit of gut fill, as we saw in that one study at University of British Columbia, where they were providing a hay-free choice, and about 20% of the diet became hay, and that resulted in considerable gut fill. So I don't know anybody who's really looked at that beyond the first couple months. But there has to be a lag effect that it would, over time, the rumen papillae would develop.
Great, thank you. We have another question coming in. In the Van Amberg study comparing the 2 levels of colostrum and 2 levels of milk replacer, was there any measure of health in that study? And were calves fed 4-liter colostrum healthier?
That data was presented at one of the joint annual meetings, and you'll notice it's an abstract, so I don't have any more data than that. Mike Van Amberg may not be happy, but I'd say get in touch with him to find out. Or Fernando Soberon was the graduate student who was doing the study and published the results with Mike, but it's only available in abstract form. So I know what they were doing. They were looking at long-term effects, so they're going into lactations, and so the data is not published because they want to have a more extensive set of data besides just the first 2 or 3 months. But in general, I would expect that they would have healthier calves that have a higher level of colostrum feeding and a higher level of milk replacer feeding. If you remember from that study with the brown Swiss calves in Wisconsin, 2 versus 4 liters of colostrum, those that had 2 liters of colostrum had twice the health and treatment costs as those that had 4 liters. So that's probably the best information we have right now.
Another question is, do you have any thoughts or recommendations for farmers that may want to transition their calves from a milk replacer or milk to a grazing system?
I think the first 2 months would be the same, and I think it's important, no matter what age you wean them, that the calves have a full 2 weeks to stay where they are. If we look at the data, which I didn't show, but the NOMS data, the most popular age at weaning is 8 weeks, and then it's 6 weeks, and then it's 7, 10, and 12. Calves do not take change very well, and the more changes occur at one time, it creates considerable stress. And when they're stressed, their immunity drops, and they're more likely to have respiratory problems. And there are field data from New York State, from the Cornell Vet School, that show that once a calf has a respiratory problem, it's essentially impaired for life. And that's what the Penn State data, field data, also show, that the respiratory days is a significant factor. So we need to make transitions for calves because they don't handle change that well. So if you're going to wean calves at 8 weeks, then I recommend they stay in a hutch or a pen for another 2 weeks so that their starter intake picks up and they have more rumen development, functional development. And then when they first go into a group, they should be in smaller groups of 6 to 8. I think that 3rd month is a critical transition period, and we don't always think about that as being a transition period. After they're 3 months of old, then I think you could put them, depending on the time of the year, on pasture, provided you still have some supplement. And that should probably still be in the 2 or 3 kilogram range for at least another month or 2, and then they can be gradually, switched to more like a heifer grower supplement. But it depends on the time of the year. If the calves are calving in the spring, then the pasture quality would generally be better, as opposed to in the middle of summer when it gets hot and dry.
Great. There's 2 more questions that I can see. Will the frequency of feeding colostrum have an effect on IgG absorption, and what's the recommended frequency?
That's a good question. There are data that show that the longer you wait to feed colostrum, the lower the absorption efficiency. That goes back 30-some years at Arizona. So it drops by about 25% in the first 4 hours of absorption efficiency. At 12 hours, it's way below 50%. By 24 hours, it's virtually nil. And it seems that there is a relationship that the very first feeding of colostrum will cause that ability to absorb the antibody proteins whole through the intestinal wall into the blood. That system will begin to shut down. So that's why the emphasis is at the very first feeding to feed colostrum, so that you maximize the amount of antibodies they get and the absorption efficiency that they have. If you split, say, 4 liters into 2 liters of the first one and then 2 liters 6 hours later and 2 liters 12 hours later, you're going to have overall lower absorption efficiency because that system will be shut down at an earlier time because of the very first feeding of colostrum. So that's why the emphasis is on the very first feeding of colostrum. There's still other factors in colostrum and higher levels of nutrition, and that's why even if you get 4 liters in the first feeding, it's recommended you come back later with another 2 liters, and that generally may be about all the colostrum you'll have on hand anyway.
Great. The last question is, how large is a calf's stomach at birth?
Oh my gosh. A calf's stomach, the abomasum, I've seen it, I'd say maybe at most a couple liters. The other parts of the stomach, the rumen reticulum, particularly the rumen, is quite small, and it's non-functional. That's the most important part. As some of the data in the 50s from Cornell showed, that even a veal-fed calf will get a larger rumen, but it's not functional because it has no papillae development. So there's some concern as to whether you should feed 4 liters of colostrum at first feeding, because what's the size of the abomasum? Well, it should be at least 2 liters, and the calf's digestive system when it's born is completely empty, and it seems to have the ability to handle that 3 or 4 liters without a problem. It may look extended, the gut, and it will be initially because of that high volume. And if you feed it, you may not be able to get them to drink any more than 3 liters. Then you have to decide, well, how important is that in the scheme of things? Some dairies will use an esophageal tube, but if you do that, you have to be really well schooled and versed on doing it properly so you don't get it into the lungs and drown the calf. And you have to make sure it's clean and disinfected between calves, or else you're passing on a bug from one to another and that sort of thing. So those are some of the practical issues that you sort of have to deal with on a dairy-by-dairy basis.
Great. Thank you so much, Dr. Kertz. If there is no more questions coming in from the audience, there should be a link being provided to everyone, so please make sure to register for our next webinar in our series titled Dealing with Infertility of Lactating Dairy Cows, the Foster Mothers of the Human Race, Evolving Perspective of an Animal Scientist. And this will be presented by Dr. Thatcher on February 19th at 12 p.m. Central Time. So again, on behalf of the Graduate Student Division, we just wanted to thank everyone for joining us today, and definitely thank you, Dr. Kertz, for taking the time to be here today to present this webinar to us.
Well, thanks to all of you.